Hi students, finally I have my video on air masses and fronts, so I'm going to jump right in so that we can get through this in a minimal amount of time. So we're going to first begin with the definition of an air mass, and I am going to allow you to pause the video at this time if you'd like to copy down this definition. That would be awesome. I'm going to simplify this definition a little bit for you. An air mass is a large volume of air that has the same characteristics all throughout. Especially when we're talking about the air mass, we're looking for it to have the same temperature and humidity at the same altitude. If you move up through the air mass, any point, if you're looking horizontally through that air mass, it's going to have similar characteristics. Now, if you look at this map, there are a lot of really funny air masses with these different letters like C's and A's and P's and T's. We're going to talk about that in just a moment, but what I want you to notice is that obviously these different air masses are forming on different regions of our globe, and we're going to come back and talk about that in just a minute because that part is really, really important because where the air mass is formed, the land or the ocean that it's forming over is going to determine the characteristics of the air mass. So how do we classify air masses? So we're going to look at one of two things. First, we look at how moist the air mass is. Is it high in humidity? Is it low in humidity? So the first that we're going to look at is humidity. The second way that we're going to classify air masses is the temperature. Is it warm? Is it cool? Is it very icy weather? So these are the two factors that we use to classify air masses. So here I've broken them out for you. Humidity. If I look at humidity, my air mass can either be formed over an ocean or it can be formed over land. And so if I'm looking at one that's formed over an ocean, we call this maritime. And if you ever have done any sort of boating, that may look familiar to you when we represent maritime with a small m. And again, these are our ocean-formed air masses. The second place that we can find our air masses are going to be continental. And just like that first part of the word, continental, you guessed it, they're formed over continents. So this is formed over continents or any sort of land. So these are going to be our dry air masses. So continental tend to be dry, ocean tend to be wet. Okay, next we're going to look at temperature, and we have two main subgroups. We have polar, and as you guessed, the polar are going to be the cooler air masses because they're formed over cooler regions. We represent this with a large P, and these are our cold. Secondly, we have tropical. Tropical are nice and warm, just like the tropics. So we do this with a large T. And then last but not least, but you don't see these much, we have Arctic, and these are formed over the very, very top pole over our Arctic circle and our Arctic region. And of course, these are the A's. Again, these are very cold because they're formed in the very top, and they're often responsible for the super cold weather that you have uncharacteristic to North Carolina. So I'm going to come back to this slide because I want to point out, now that you look at this globe, it may look a little bit different to you. You have maritime tropical, maritime polar, continental Arctic, continental polar, maritime polar, and maritime tropical, and down here we have a continental tropical. All of these are formed either over land, these are all continental, or oceans. Okay, you may also look that you have some that are formed in cold regions. Here are my Arctic and polar, and some that are over warm regions. Here are my tropical. So these air masses, again, are going to take the characteristics of the land or oceans that they're formed over, the parts of the continent they're formed over. Okay, we're going to keep it moving because the next thing I'd like to do is introduce you guys to cold fronts. Now, sometimes when you're looking at a weather map, you'll see this crazy line with these oh so cute little triangles on it. And usually they're a darker blue. I'm going to use a light blue this time. Your welcome to copy down the things from cold fronts. I've outlined it all in red, but please copy down the things under cold front that you find to be the most important. A cold front happens when you have a cold air mass that comes to a region that there is warm air. So you have some warm air that's hanging out. Typically that air tends to be moist, and this cold front comes in very, very quickly. And they runs into the warm air and very quickly slams, push the warm air. Some of the warm air rises, and then you have the warm air being pushed out of the region. Typically, you know you're having a cold front because you'll have warm weather, and then all of a sudden, maybe that's that morning, you leave out the house later on that afternoon, and all of a sudden it's freezing cold outside. Often what you will see as the cold front is passing, and this is a pretty good sign that you're having a cold front, you will have wind, intense rain, and thunderstorms as the front is actually passing. This is, it turns from a region of low pressure into high pressure. So often with the cold front, you will see kind of weather that is maybe cloudy and moist. To all of a sudden, you'll have intense thunderstorms, and then your skies will clear, and the weather, the temperatures will drop, and you'll have much cooler weather outside with a cold front. Warm front. So on my weather map, where I had those cute little blue triangles, now I'm going to have these cute little red semicircles. Okay, this is going to be a warm front. The warm front happens when you have cold air in a region that's moving slowly, and you have a slow-moving warm air mass that comes up, collides with it, and the warm air slowly starts to rise, but it pushes the cool air out of the way. You will often see warm fronts do not happen as intensely and abruptly as the cold front. So often you will see rain, but that rain will be very gentle as the front is passing, and it may last a little bit longer than like a cold front. It's going to get warmer gradually, and you're going to have, again, a drop in air pressure. So high pressure is going to turn to low pressure. Those clear blue skies are going to turn gray and cloudy. Okay, and I wanted to go ahead and give you a little bit of a diagram so that you could understand. We sometimes I like to refer to, this is your cold front here. I like to call this cold front the bully. I'm going to change colors on that because that is not very easy to see. Oh, let's see if this will work. Not much better. Okay, we'll just write it over here to the side. Okay, this is my cold front. What happens in the cold front is I have this cold air, and it's coming in like a big, huge bulldog into the region, and it is going to take this warm, moist air. As it hits the warm, moist air, this warm, moist air is forced upward, and that warm, moist air is full of moisture, full of little water vapor and water droplets. It's going to be forced up so quickly that it's going to produce these thunderstorms and rain. As the cold air has passed, you will then have, or as the cold front has passed, you will have the cold air mass, the polar or Arctic air mass hanging out in that region. So these temperatures are going to drop. Okay, dropping temperatures. Okay, my warm front. So here's my warm front. Again, does not happen as abruptly. I have cold air. It's kind of hanging out in the region. It's hanging out here. You have these beautiful skies. And slowly the warm air is going to come into the region. Now, as the warm air hits, we all know from earlier in the lesson that warm air, it likes to rise. And so as it rises, you're going to have this little bit of rain that's being formed. You're going to have this rain that's kind of going to be formed. That's going to be in light showers. You may not even have any precipitation. You just may have cloudiness forming, but that's what's indicated by all this here, those clouds that are forming. So again, this is your warm front, and of course, you're going to have increasing temperatures with a warm front, and that may be gradual versus the cold front where temperatures drop very, very quickly. Stationary front. Sometimes you have cold and warm air mass that meet, but neither one has enough power that's going to move the other one out of the way. They face each other, and I love this word, standoff, and it results in a stationary front. Now, if you see a stationary front, It's it's pretty apparent on a map because you're going to have a really weird line because you're going to have a cold front marked on one side and you're going to have a warm front on the other. So this is what a stationary front line looks like on a weather map. There's typically no change in weather or pressure because it's moving back, forth, and it often rains for days at a time, and you typically have a lot of clouds from this moving back and forth, back and forth. I went ahead and I just included this. This is going to show your cloudy weather. It's going to show how I have my cold trying to come in, I have my warm trying to come in, and eventually one's going to win out. But a stationary front, and again, I'll mark this as stationary front, you do see on a weather map frequently, and often they're mixed in near a warm or cold front. And so this is a region where you'll have, sometimes you will have rain with these for days and days and days at a time. Okay, last but not least, and this is probably the most difficult for students to understand, is the occluded front. The occluded front is when you have a warm air mass caught between two cooler air masses. It's complex and very rare. You may or may not see this on a weather map. Sometimes they look like this. Oops, excuse me, this would be a triangle. Sometimes they'll look like this with both on one side. Sometimes you may even see it done in purple. In the same way with the stationary front, I've occasionally seen it. Sometimes you may see it purple because you have, same way with the stationary front, you have the warm and cool air mixing, so they will make that purple with the red and blue combining. So I wanted to show this because it is a little bit challenging to understand, but just talking through it. But with the warm, the way that a occluded front happens, okay? You have some cold air in a region, okay? Cold air is in a region. Warm front comes in. The warm air presses up and over, just like you see right here in this part of the diagram in part A. As that warm air mass is pushing the cold air mass, and you've got that light rain, right behind the warm front comes this cold front. So you have a warm front that has a cold front right behind it. The cold front is going to come and it is going to slam into the back of the warm front, and it's going to trap a bunch of warm air at the top. You're going to have cold air from one air mass, cold air from another, and you see even here in this, they've given me my occluded front as a purple, indicated in purple. So that's the end. I don't want to keep you much longer because I've already far exceeded my 10-minute limit. Again, please make sure you have these copied in the appropriate page of your notebook, and certainly let me know if you have any questions. Thank you so much.